Algebra 1, this is 4.4. This one's going to be scatter plots and line of best fit. So what we have here is we have scatter plots, and we're going to talk about is correlation. So correlation, guys, is how well do things, is there a relationship between things? So we have three different types of correlation, guys, and scatter plots is just showing that correlation or that relationship between two variables, and you graph them as points. Okay, so what we have in the first box here is a positive correlation. The positive correlation just says that as the x value goes up, the y value goes up. Another positive correlation you probably could think of in real life is the more hours at a job that I work, the more money that I will make. A negative correlation, on the other hand, is when the x gets larger, the y falls or goes downward. And so, let's see. This one for a real life situation would be the more hours I work out, the less weight I weigh, say by week or something. Kind of giving an idea that the more you do something, the less it ends up being. And then the final one is something called no correlation, and sometimes they just call that as a scatter, is that you cannot discern any particular given thing, a relationship that actually is happening. Now each one of these is a relationship between inputs and outputs. It's just that sometimes you can't put a rule to it. Okay, so that is something that we're going to be talking about. Now notice that those red lines on the positive and negative correlations, that is called the line of best fit. Now notice that it is in the middle of the data, and it is not at the first point and last point. I think some of your middle school teachers have done you a huge disservice, and they say, oh, it has to go through the first data point, which is like there, and the last data point, which is there. And if I was to do that, I'll change it to purple here. If I was to do that and connect those, I know it's not perfectly straight, but that's a totally different line, right? Even here, if I start and go like this, that's a totally different line than that initial red line that they have there. So do not use the first and last points. You have to go straight down the middle. Find the middle between those two. Okay, so that is what we're going to talk about as scatter plots. So, the first examples that we have is that I need you to evaluate the type of correlation. And so, I want you to determine whether these two graphs has a positive, negative, nor correlation. If there is a positive and negative correlation, describe what it means, what's happening. So, looking at math scatter, the math final grade, and your SAT math scores. So that's just one of the scores that would be for an entry level to get into college, is the SAT. So do you think you can see any discernment of, as my math final goes up, do I get a better SAT score? Well, it kind of looks like it's happening over here. But then I also see that it's high over here, people scoring really well on the SAT, but yet not doing very hot on the final. Getting a 40-50% on the final is probably not the best. So, I don't know. I don't think I can say that this is a positive or a negative correlation. There's no particular line that I could draw that would represent this data very well. So the first one, I'm going to put no correlation. No correlation. The second one, the car's age versus price. Well, this kind of makes sense here, is that as the car gets older, usually the cars lose value. So as you can see that as the years go up, the value, which $4,000 for a car, this must have been like back in the 70s or 60s, and the value goes down. As X gets bigger, Y's are going down. That is a negative correlation. And it says explain what your meaning is that as a car gets older, it loses value. That is a negative correlation. Years are getting bigger, cost or value is going down. So that's pretty simple, right? The idea that you have to talk about, is it a positive, negative, no correlation. So what are we going to do with this information? Well, what we're going to do is we're going to do something called the line of best fit. Guys, the line of best fit is a trend line that follows the data. So, big word there, follows. I'm going to actually circle that. Follows the data. You don't have data. I'm going to go backwards here. I wouldn't look at this particular graph and say that line right there that I just drew is a really good representation of that data. Because lines of best fit, guys, are lines that we want to use to predict the future, predict the past, and predict what's going to happen within that data. So there is actually two types of predictions. When you are, I'll take that line out. So this line right here, well, maybe not that one. This line right here, that purple line that I just put on there now, would probably be a good linear model of the data. Now it's not going to be perfect because obviously you can see there are points above the line, points below the line. But if I was to tally those up, I try to balance it. There's half above, half below. Now, I can use this and I can say what would an average cost then at 4 years. So at 4 years I go straight up to my line and I would say, hey, it's about 2,000. Or it's at 2 years. At 2 years, it would be roughly 3,000, it looks like. And so I was able to use my line to gather data or find values. When it's inside the data, it's called interpolate. And if you outside the data, extrapolate. So that's two different words there that they use. I'm not going to be picky and force you to know those words, but it's either inside, interpolate, and outside, extrapolate your data. So how do I find that line? Well, here's a cool thing. You make that scatter plot in step 1, as in that car and age and value. Is there a relationship? So is it a positive relationship, negative relationship, things like that? Let me go back real quick. If the line is falling, what kind of slope is that? It's a negative slope. What kind of correlation is it? It's a negative correlation. That is really cool. Okay? So, we got a correlation going on. I drew a line that seems to pass through most of the data. Splits it in half. I already talked about that. Then, I have to use 2 points on that line. Guys, it's very important. Just don't use the first point and last point. If your point is not on your line, don't use it. If there are no data points, so if I have some data here that's like this, and I draw a line right through here and say, there's my line of best fit, and it hits none of my points. As you can see, none of these points are on that line. It's okay. You're going down the middle. And so what you need to do is you need to pick 2 points on your line of best fit. Pick nice ones. Pick ones with nice numbers, like 5, 4, right? So maybe this is like 5, 4. And this one ends up being like 1, 1 or something. Guess what? You find nice points on your line, because then you can do exactly what you did in 4.1 and 4.2, and that would be to find the slope using the slope formula, then using point slope, using one of those points in the slope, you can find slope-intercept formula line. And that's exactly what we're doing. We're finding the equation so that we can talk about our data better. So, your homework here, guys, and I am going to leave this one a little bit more open-ended, is I want you to do just these 2. I want you to tell me, is there a positive or negative correlation? Describe its meaning. But then, I also, in part B, I want you to find the line of best fit equation. So yes, you have to tell me, is it a positive, negative, no correlation? What does it mean? And then you actually have to go through those 4 steps. Find your points, find your line equation. Have a great day.